All right, welcome back. We are jumping right in today because we are opening up a high-stakes survival playbook. Look, if you're prepping for the NEC license exam, you probably already know the C programming section can feel like a total minefield. But here's the secret. Mastering C functions is literally the key to unlocking easy, guaranteed points on this test. In this explainer, we're going to totally dismantle the test maker's favorite tricks using this complete cheat sheet. We are going to take those complex, panic-inducing code snippets and turn them into predictable patterns that you can solve in seconds.
So here is our roadmap. 1. Anatomy and prototypes. 2. Value versus reference. 3. Demystifying recursion. And 4. Defeating exam traps. Section 1. Anatomy and the mandatory prototype rule. Okay, let's dive into this. To absolutely crush this exam, we first have to establish the ground rules of where a function actually belongs in your code. Imagine you're sitting in the exam room, right? And you see this block of code. The function you're calling is defined way down after the main function, but there's no prototype at the top of the script. What does your gut tell you? Will it even compile? Take a second. If you hesitated there for even a moment, the exam writers have you exactly where they want you.
So here is the golden rule, straight from the source material, and honestly, you should burn this little rhyme into your memory. Define before main, no pain. Define after main, add prototype chain. It really is that simple. If a function is fully written out above main, you don't need a prototype. It's totally fine, no pain. But if you define it after main, a prototype at the top of your code is absolutely, strictly mandatory. Without it, you're going to get a compiler error, and believe me, that is a classic NEC trap. Now, what's really interesting here is how ridiculously picky the compiler gets when checking these prototypes. Take a look at these specific components. If you do need a prototype, it has to match the actual function definition almost perfectly. The return type has to match exactly. The function name, yes. The number of parameters, yes. The type of each parameter in the exact right order, absolutely yes. But check out that bottom row. Parameter names, no. The compiler completely ignores them. There's no way they won't try to trick you with this. They'll put a prototype like void test int x and a function definition like void test int y. That is completely legal. But if the type changes, say from an int to a float, that's a guaranteed error.
Section 2. Passing arguments. Value versus reference.
Okay, misunderstanding how arguments are passed into a function is hands down where the vast majority of test takers mess up. Think about it like this. Call by value is basically like handing someone a photocopy of your notes. They can scribble all over their copy, cross things out, change the numbers, but your original notes sitting right there on your desk, they are perfectly safe and entirely unchanged. Call by reference, on the other hand, is like giving someone a link to a live shared Google Doc. You're giving them the actual address of the document. If they make a change using that address, boom, the original document is modified forever. In C, call by value passes a copy. Call by reference passes the memory address using that little ampersand symbol, and it uses pointers to modify the original data. So the crucial point is how this actually shows up on the test. Enter the classic NEC swap trap. The exam is going to show you a swap function that takes two integers, let's say a and b, by value. Inside the function, sure, they swap perfectly. But when you check those original variables back in main, they haven't changed at all. Why? Because the function only swapped the photocopies. It's basically a programmatic illusion. To actually swap the original variables, the function must use call by reference. It requires pointers, asterisks in the parameters, and ampersands when you actually call the function. If you do not see pointers in a swap function, your answer should always be values remain unchanged.
And that brilliantly brings us to the ultimate exception to the rule, arrays. Look closely at the passing mechanics here. A standard integer, int x, passes by value, so it cannot modify the original. A pointer, int star p, passes an address and can modify the original. But look at int air brackets. It passes an address. Wait, why? Well, because in C, an array name automatically decays into a pointer to its very first element. So if you pass an array into a function, you are inherently passing it by reference. The function absolutely can and will modify your original array data. Whatever you do, do not let them trick you into thinking arrays are safe like normal variables.
Section 3. Demystifying recursive functions.
All right, deep breath. It's time to tackle the notoriously panic-inducing concept of recursive functions. For a lot of people, this is basically the final boss of the exam. When test takers see a function calling itself, they just kind of freeze. But I promise you, it's just a mechanical pattern. A recursive function is simply a function that calls itself. But to prevent it from running forever, it absolutely requires two mandatory parts.
First, the recursive case. This is where it calls itself to keep the loop going, breaking the big problem down into a smaller piece. But far more importantly, it needs a base case. This is the condition that tells the function, hey, stop calling yourself and finally return a real number. The exam loves, and I mean loves, to test this using standard patterns like factorial, power, Fibonacci, and sum of digits. Listen, if you are ever scanning a recursive function on the exam, the very first thing your eyes should look for is an if statement acting as that base case. The source material gives us another awesome memory trick for this. No base, no grace, Stack Overflow in your face. It's hilarious but true. If the exam shows you a recursive function missing its base case, don't even waste your time trying to trace the math. The code is just going to trigger infinite recursion, completely run out of memory, and crash the system with the Stack Overflow, probably right as your computer's cooling fans start sounding like a jet engine.
But hey, what if the base case is there and they ask you for the output? Whatever you do, do not try to do it in your head. Just use this simple 4-step mechanical method. Let's trace a factorial of 4 together. Step 1, identify the base case. For a factorial, it's usually if n equals 0, return 1. Step 2, write out the calls going down. Fact of 4 needs 4 times fact of 3. Fact of 3 needs 3 times fact of 2. All the way down until fact of 0, which finally hits our base case and returns 1. Step 3, unwind from the base upward. You literally plug that 1 back into the previous equation. Step 4, calculate. 1 times 1 is 1, 2 times 1 is 2, 3 times 2 is 6, 4 times 6 is 24. Honestly, just write it down on your scratch paper exactly like this, and you'll never get a recursion question wrong again.
Section 4, Defeating NEC Exam Traps.
All right, we are in the home stretch now, and it's time to gear you up with some rapid-fire strategies for test day. Real success on the NEC exam is all about pattern recognition. The second you see specific keywords in a question, your brain should immediately deploy the corresponding strategy. If the question asks, what is the output? Your immediate reflex must be to trace it step by step and intensely watch out for those call-by-value traps trying to fake you out. If the question asks, will this compile, or is there a compiler error, literally stop looking at the math. Just immediately check if the function is defined before or after main, and see if the prototype matches exactly. If the question mentions swap values, instantly scan those parameters for pointers.
I want you to take a mental screenshot of this final checklist right now. Before you select A, B, C, or D on any function-related question, just run through this list. Is the function defined before or after main? Do the prototype and definition actually match? Is this call by value or call by reference? Did they pass an array, meaning my original data is going to be modified? If it's recursion, did I actually find the base case? And lastly, double-check those format specifiers. Make sure they're using %d for integers and %c for characters.
Mastering these specific rules takes all the guesswork completely out of the equation. C functions aren't magic, you guys. They're just strict sets of rules that the exam writers use to test your attention to detail. So I want to leave you with this final thought. How are you going to apply this systematic, trap-spotting mindset to the rest of your NEC exam prep? Because if you can break down functions into predictable patterns like we just did, you can do the exact same thing for pointers, structs, and memory management. So keep this cheat sheet handy, stay laser-focused, and go absolutely ace that exam.